This is how to solve question 206 from chapter 3. The full question is in the description, but for now I'll read what we need to find. So what we need to find is, it says determine the width of the square. So we're going to find the width of the square concrete bar and the rate of heat loss per meter length. So let's start by writing the givens. D equals 127 millimeters, and that's the diameter of this. K is 1.7 W. Okay. T1 is 120 degrees Celsius, and that's the temperature of this pipe here. T2 is 0 degrees Celsius, and that's the surface of this square bar. Next is T infinity, that is -5 degrees Celsius, and that's the temperature of the air around the whole thing. And then we have H, just 20. Alright, so we need to find this. First we get the shape equations. So shape equation is, for this is 2 pi natural log 1.08 W, that's the width, and then that could also be written as alright, so now we have these. We go and try and find the heat loss per unit length. So loss per unit length is shape equation times K T1 minus T2. And then we can do some substitution. And now we have the divided by 27, 2 pi on top, times the 1.7 we got from this K up here, and then T1 minus T2, we have those there. It's just 120 minus 0, which is just 120, right? And when we simplify that down, we get divided by and again we're trying to find this W, so we need another equation. And to do that, we calculate the heat from the surrounding bar. So this was for this bar, that's why we use T1 and T2. This is T1, this is T2. Now we're going, from T1 to T2, and now we're going from T2 to the surroundings. So we do, that's H, A, T2, is T infinity. So we have H is 20, which was given. Now for the area, we do surface area. So since we're doing, this is like just a cross section of the entire bar. So we have 4 of these, and since this is a square, these two are the same height, same length, I mean. So it's just W times L times 4, basically. So it's 4 times the width times 1, since we're doing per unit length. That's what this L is. And then we have the T2, which is 0 minus T infinity, which is -5. So that just ends up being a 5. So when we simplify, we end up with 400W. So now we set these two equal to each other. And then using algebra once again, the width is 1.32 meters. But we're not done there. We still need to find the loss, Q loss. So plug it back in to the Q loss equation from here. And what we got was this. So no sense in writing all this out. 1281.77 divided by 8.504. And then instead of this W, well, we put the W, right? And then this W is that's what we just found. We plug that in and we get 530. So that's that answer, and that's the other answer.